So right here we would consider this to be a bearing. And we would say north 30 east. North 30 east. So that means what they're telling you is you're going to come off the north line and you're going to go 30 degrees east. So you'd go north 30 degrees east, you'd go off to the right 30 degrees, and you would draw a ray right there. Okay? So this would be the 30 degrees off of your north line in the direction of east. Okay? And that would form this angle right here. Okay? Let's come down here. Let's go to point 2. Okay? Point 2 is down here. Point 2 is down here in the third quadrant. So they gave you a direction of south 50 degrees west. So south, so you're down here, 50 degrees west, you're going to go 50 degrees to your left. And that would give you south 50 degrees west, and that would give you this one right here. Okay? And if we look at point 3, the bearing on point 3 is north 70 west. So north 70, so off your north line, you're going to go west, so you're going to go off to the left by 70 degrees, and that would be your 70 degrees west. Okay? So looking at those, what can you conclude the bearing would be for point 4? What line are we off of? Is point 4 off of the north line or the south line? It's off of the south line. And we moved to the right. So we did south, we went 20 degrees, and we went to the right, so it was east. So the bearing for point 4 would be south 20 degrees east. Okay? Any questions on that? So if you'll notice a couple of important things here. These, did you notice that these were all acute angles? Did you notice that these directional bearings were acute angles? Okay? And then the other thing you need to understand is that they are measured off the vertical north-south line. Okay? They all come off the north or they come off the south. They will not come off the east or west. Some of you tried to connect them to the east or west. Only connect off of the north or south. Okay? So be real careful with those. So for example, on number 3, you had north 42 east. So northeast, I'm going to come in this quadrant. And I'm measuring off the north line. So this would be my north 42 east. Number 4, we have south 31 east. So we're coming off the south 31 degrees toward the east. So we'd be over here. And notice I go back to the south line for the measurement. And number 5 down here, north 52 west. So I'm back up here at north 52 west. Now I'm going to go off to the left. And I measure back to the north line. Okay? Any questions on those? Now, the other way that you will see these are where they don't have the directions. These other ones, remember, they had northeast, north 30 east, or south 50 west. They had those markings. All right, what if they ask you to do a bearing of 30 degrees? A bearing of 30 degrees. Well, what is it? Is it north? Is it south? Is it east? Is it west? They don't tell you. They don't tell you, okay? In this case, you measure off the north line in a clockwise direction. Okay? You'll measure off your north line in a clockwise direction. So if I kind of extended this thing on out, you'll see that a bearing of 30 is up there in quadrant 1. And I started off my north line and went 30. Okay. So if they do not give you the directions as far as north or south, east or west, they just give you a bearing. You always start from the north line and you go in a clockwise direction. Okay? So do those first two for me on the worksheet. Okay, so let's look at the bearing of 32. So I'm going to come off my north line right here. I'm going to go 32 degrees, so I'm really going to be right there. So there's my 32 degrees. Down here on my bearing of 304, I'm going to start on the north line. I'm going to end up where? In quadrant 2. I'm going to end up all the way over here. I go to 90, I go to 180, I go to 270, and then I'm going to end up over here. And that's my 304. Okay. Any questions on those? So 2 ways that you will see these. You'll see them with direction. With direction, that would be like these over here. And if they just give you a bearing, you'll start off your north line and you'll go as far as the degree will take you. Okay? Any questions on how we draw the bearings? All right. Okay, let's take a look at an example.
Will it ever be more than like 360?
No, because then you'd be doing this,
Because I don't want to do that.
and you get dizzy like I'm getting dizzy right now. Okay, so we stop there. All right. So first thing we're going to look at is our bearings with our right triangles. So I'll give you a second to copy this down. So if we are given we're going to be given some instructions or directions on what's happening. Okay. In most cases, it'll be maybe a pilot flying a plane or a ship, or just a person maybe walking. Okay, and we'll be given some directions. If in those directions we get some information that we have a 90 degrees somewhere, then we are just working with our normal right triangles. Okay. So we would graph our bearing, just like you practiced here a second ago. Then, per the directions or the instructions, we're going to actually construct a triangle off of our axis, and we would draw that. Okay. And then we would figure out whether or not we have the 90-degree angle. If we do, then if we have our triangle drawn, then we will figure out what they want us to find, and we will go back to our SOHCAHTOA, our sine, cosine, tangent, to solve the triangle. All right, draw your XY axis. Okay. Now, draw your north 20 east bearing. Draw your north 20 east bearing. And the pilot went how far again on this one? 1 mile. Okay. And then he's going to turn that 90 degrees north, west. So now we're going to go back which direction? Yeah, we're going to go back to the left, right? Northwest. So remember, our west is over here. Remember, this is our east. And our west over here, north and south. So we're going to head back. Make yourself a 90-degree angle. You know that that's 90 degrees. They told you that, in fact, didn't they? So there's your 90-degree angle. And they told you that he went that far for how long? 2 miles. And then the control tower wanted to contact them. Where's the control tower? Where's the airport? At the origin. Yes. So here's your tower. So we need to complete our triangle, do we not?
Yes.
Okay. So complete your triangle. You've got to connect the tower to the airplane. So connect your tower to the airplane. I'll try to do it. Well, let's see. I'm going to have to extend. Okay, we're going to kind of fudge it up there. There we go. You guys can do a better job than me. All right, so at this point up here, where the plane is now, what bearing should the control tower use to locate the aircraft? So now they basically have a new bearing, and remember, your bearing is off of your north-south line, so now what we're looking for is this angle here. Remember, this is not drawn to scale, okay? So this is really not drawn, but that's what. Okay, so now what we need to do, let's talk a minute here about what we're going to do. Okay, so we're going to take this angle, we're going to solve this angle right here. We have these two sides. We have this side and we have this side, and we're going to solve for this angle. What's going to tie those together is tangent. So I'm just going to do tangent of theta, and that would equal what? What's our ratio? 2 over 1, opposite over adjacent, right? So find the inverse tangent of that for me, and what does that give you? (63.4). Okay, so now I have found this angle to be 63.4. Now how can I find my bearing? Subtract what? Yes. So I'm going to take that 63.4, I'm going to subtract out that 20-degree bearing that we already had, and that leaves us with what? 43.4. Okay, we're going to start at the origin. Okay, and that's going to be, we want to find the bearing to the what? To the, what's going to be in the origin? Hospital. So we're going to label the origin the hospital. Okay? Wow. Now, Wendy works 7 miles due west and 4 miles due north. So where are we going to go from the origin? 7 miles west. Where are we going to go? West. So we'll go 7 miles west. Let me change color. Nope. Okay. So 7 miles west, and then we're going to do what?
We're going to go north.
Then we're going to go due north. So we're going to go straight up north. So there's your 90-degree angle right there. So we're going to go due north 4 miles. Okay? And right there is where? What's right there? Is that Wendy's house?
Yes.
Okay, so there's Wendy's house. So we're going to do what? We're going to finish drawing our triangle. So finish drawing your triangle. Yep. Let me see if I can clean that up a little bit. I'll get a little closer in. All right. Now, what is the bearing of the hospital from Wendy's house? The hospital, or I'm sorry, the bearing is measured where? Bearings are measured off of what? The
y-axis.
yes, the bearing is measured off the y-axis, right? So the bearing is actually where? What do we want to find? We actually want to find this right here. We want to find this bearing. Okay? All right, so I'll just label this one theta, because let me read. So how are we going to find theta? How would we find this one? Sine, cosine, or tangent? Sine, cosine. Let's put the 90 in. There's the 90. Sine, cosine, or tangent? What side is this right here? Is that the hypotenuse? Okay. Do we have a value for the hypotenuse? No. So which function do we need to be using? Tangent. All right. So tangent. I was going to go ahead and put the inverse on in there because we know we're going to do that anyway. What's our ratio? What over what? 4 over 7. Okay, what's that going to give? You put that in your calculator for me?
29.7.
20.
29.7.
He did that with his brain.
Okay, so if this angle right here then is 29.7, how are we going to find the bearing?
Subtract it from 90.
What would that give you?
60.3.
60 point?
60.3.
Excuse me. So that would give us a bearing of the hospital to Wendy's house of 60.3. So if we want to, let's label that. Let's label that with directions. What would that be labeled as with directions? North. I like it. There you go. Good job. I'm sorry, what? Well, I kind of did this right here, and you could do the same thing, but I'll know what your bearing is if you label it, right?